All right, so welcome everybody to week 3 of StarkNet Basecamp. It has been a really exciting journey with you all, and it's amazing to see that we are finally coming to the end of it together with you all. So today's session is going to be about Starklings, and we have Lynette that's going to take us through Starklings, the tips that you would literally use to complete the Starklings challenges. These challenges, once you complete these challenges, they will qualify you to graduate from this StarkNet Basecamp at the end of it all. And definitely we will give you a reward maybe a certificate at the end of it. And so, yeah, I hope that each one of you is going to actually find this session really, really helpful and resourceful, because from tomorrow it's going to be a self-paced session, hence why you were added to teams. So let us know in case you are not yet added to any team. Then we will be sure to add you. Just drop us your GitHub link in the StarkNet chat, and we will definitely add you to the GitHub, so it's easier to collaborate and to tackle all these sessions and challenges together with your team members, and just encourage peer-to-peer learning and peer-to-peer educating each other. So yeah, Lynette, let me know if you can speak and if you can share your screen, and we can get started.
Okay, thank you, Lavender. I hope you can hear me.
Yes.
Awesome. So I'll just share my screen.
All right.
Can you share access?
Oh, okay. Yeah, just a sec. Just a sec. Should be here. Okay. All right. Let me know if you can share now.
Yeah. Okay.
Nice.
Can you see my screen?
Yes.
Great. Okay, so I think I'll just start by introducing myself. Hi, everyone. Welcome to week 3 of the StarkNet Basecamp again. I'm going to be taking you through the session today, which is going to be more practical on Starklings. And we're going to be tackling some of the exercises with you guys. So if it's possible, you can code along on your machine or with me. And also, I'm working on the assumption that you have already set up your environment by installing Rust, Cargo, and all other necessary dependencies from previous sessions. If you have not, then I would advise you to check out the recordings that were shared. Okay, so Starklings is basically just active exercises to practice Cairo programming. So while you're learning, it's very advisable to complete them. And this is the repository that has the exercises. So I think I'll just share that. Okay. I'll share the link in the chat. And then we can start by cloning that repository. Yeah, so make sure you have Rust and Cargo installed before you can start. And then open it in our terminal or in our code editor. And then we're going to, first of all, run this command to set up our environment.
Sorry, Lynette, can you drop the link to the GitHub in the chat, please? I don't know. Can you hear me?
Yeah, I can hear you.
Nice.
I've sent it. Can you see it?
Yes, thank you. Just saw it.
Okay, so we'll just wait a few seconds, hopefully, for this to finish, and then we can carry on. And while we're waiting, there are also some, you can access the exercises online, and you can connect your GitHub so that you can record your progress. So if you'd rather use the online tool, then you can also access it. Hussein, can you see the link now? Okay. Okay, that's actually taking a bit longer, but let's just wait.
Okay, so feel free to also just create a repo in your specific designated GitHubs that you are added to, and so it can start to show that you have been building during this Basecamp, just to keep traction of all the exercises that you have done and all the challenges you've explored, and potentially all the projects that you have built or you'll be building throughout the code base session.
Yeah. Okay, so we're done, and we can read some instructions here. In order to start, we'll run this command, and it will automatically start with the first exercise. And the error message actually helps us to see which is the next exercise to tackle. Yeah. When you have solved, we have to remove the I am not done comment to move to the next exercise. Okay, so let's run this command for watching. Okay, so we're going to start with intro1.cairo. That's the first exercise. And this code is compiling successfully because for any Cairo code to compile successfully, there must be a main function, and that requirement is fulfilled in this one. So there's not much to do here. If we want to move on to the next, we'll just remove this comment, and then it automatically runs the exercises. So next is intro2.cairo. Yeah, so here, kind of the same thing. We have to make sure that we have a main function in order for our code to compile. So that's fn main. And then with that, it should be able to run to compile successfully. Yeah. And then remove the comment. Yeah. And the next exercise we have to tackle is variables 1.Cairo. Okay, so make me compile. Okay, so the issue here is in order to define our variables, we have to use the let keyword. So to solve these errors that we're getting, we need to add let before our variable name, and then it should compile successfully. Yeah, and it prints X is 5, meaning it has worked. Remove the comment, and let's see which one is the next exercise. Oh, it's variables 2. Let X, if X is equals to 10, print that. So all the commands you need to start the Starklings project are in the README file. So after you've cloned, you run this bin Starklings to start it, and then to run in watch mode, you have to run this third command here, in the README file. Okay, so let's carry on. If you have any issues, you can just ask. So here the issue is we have to assign a value to our variable in order for it to compile so that we can compare and print out the correct message. So we can try with different values. First of all, we can try with 10, and we expect it to return this. And that's what we get. And then if we were to have a different value, maybe like 12, then we expect X is not 10. Yeah. So we're done with that one. And we can move on to the next one. Let X fell to 52. So again, the issue here is we've not assigned a value to our variable, even though we have given it a type, we have specified the type of our variable, we haven't assigned a value. And we can have any value, so maybe like 10. And X is 10, but we can also have something else, maybe like a short string, like hello. So what we see here is the felt to 52 type, which can handle most of the different types in Cairo. And as you can see here, it still prints our message, but our hello is printed in terms of numbers. So this is the hexadecimal value of hello. So what has happened is it has just decoded the ASCII characters of our short string and printed out the hexadecimal value, concatenated hexadecimal value. So it can work with any of these for the felt 252 type. Okay, I think now we can move to variables for let X equals to 3, print, and then X is equals to 5. Yeah, so what is happening here is we are changing the value of our variable X. And in Cairo, all our variables are immutable by default. And if we need to change the value of any variable, we have to make sure that it's mutable. And the way we do that is by adding the mute keyword right before the variable name. And then you can update the value anywhere in the rest of your code. So you can now see it first prints the original value 3, and then x is now 5 after we've changed it. So this brings to focus the mutability aspect of Cairo. Okay. We can move to variables 5 for now. So let number equals 1 of type U8, and then we print it. And here we are assigning a new value to number, and then we want to print that value. So we can't change this line, meaning that we can't make our variable mutable. So what we are going to, or what we're facing here is what we call variable shadowing. And variable shadowing is changing the value of a variable by redeclaring it. You're just creating a new variable, but with the same name. Okay. Is that better? Is that better? Chaliga. I hope that's better. Yeah. So yeah, as I was explaining, okay. So as I was explaining, since we can't change this line, that means our variable is not going to be immutable. So that will lead us to variable shadowing, which is changing or redeclaring our variable with the same name, but a different value. And for that, we have to use the let keyword again. So what happens is this new variable declaration overshadows the old one. And any other time that you call this variable number in your code, it will always refer to the value 3 or the new value. So as you can see, it's working now. And then another thing with variable shadowing is you can change the type that is stored in that variable, since essentially we are just declaring a new variable, same name but different variable. Okay. I think with that we can remove this comment. And then we move to the next exercise, which is variables 6. Okay, so here we are looking at constants, and constants, unlike variables, cannot be mutable at all. Even if you were to use the mute keyword, you cannot update the value of a constant. And then another requirement of constants is to use all uppercase in the name. So we also have to specify the type of our constants. And this is because Cairo is a statically typed language, meaning you have to specify the types. So here we could have U8, since this is a number, or an integer. And then for here, we can also have U8. In fact, for this small number, it has to be U8 because we have explicitly specified using this suffix that 3 is of type U8. So if you were to use, for example, U64, it still would not work, right? You see, so we have an issue on this line. So there it has to be U8. Meanwhile, for number, since we have not specified in our value, it could also be U64. Yeah. So for every constant, you have to you have to specify the type of that constant. Okay, moving on. The next one is primitive types one. Okay, so primitive types basically just refers to the basic data types of the programming language, in this case, Cairo. And in Cairo, primitive types are divided into two groups. There's the static data types, and then there's the compound data types. For static data types, they just have a single value, and they're also divided into three. There's the Boolean, which, if you're familiar with other programming languages, it's basically just true and false. Then we have integers, and then we have felt. So let's see. Fill in the rest of the line that has code missing. And here we are testing for the Booleans type. Let is morning be true. If is morning, print good morning. Then we have to finish the rest of this line like the example, or make it be false. Okay, so here we are checking for is evening. So our variable name is definitely is evening. And then we can assign it to true. It should work. And here we can see it's printing both good morning and good evening. But if we have it as false, then it will not print good evening. It just prints good morning. So we just have to specify. And then another important thing to note with Booleans in Cairo is you cannot use 0 and 1 to represent them. So you can't say like 0 instead of false. That will not work. It will not work as expected. This is a different type. It's not a Boolean. So if you're dealing with Booleans, you have to use specifically true and false. Okay, I think we can proceed to the next one. And that's primitive types 2. Okay. A short string is a string whose length is at most 31 characters and therefore can fit into a single field element. Short strings are actually felts, they're not a real string. Note the single quotes that are used with short strings. Yeah, so in Cairo, we don't have a native type for strings. They're just felt to 52s as well. But if you were to use single quotes, then that's just a short string. And then another thing with short strings is we're going to be comparing with the hexadecimal value of that character, of that ASCII character. If you can remember when we were dealing with hello in a previous exercise that we've just done, it returned as some numbers, which is the hexadecimal value of hello. And if you're familiar with the ASCII characters, yeah, all of these are represented. So, for example, lowercase a in hexadecimal, its hexadecimal value is 61, and so on. So if we had h for hello, the lowercase h in hexadecimal, that's 68, and so on, right? Okay, so let's see what we have here. My first initial is C. If is alphabetic, then we print alphabetical, and if is numeric, we print numerical. So yeah, okay, we have the is alphabetic and is numeric functions here, which take a reference to a felt to 52 character and return a Boolean. So if character is less than or equal to a, lowercase a, and sorry, this is greater than, and then less than or equal to lowercase z, then return true. Same case for uppercase. And again, here, if you're wondering why we're using the greater than and less than, it's because we're comparing the hexadecimal values. So we're saying if the hexadecimal is greater than or equal to 61, but less than or equal to 7a, then it's alphabetic. And the same case for uppercase characters. And then our isNumeric function checks for from 0 to 9. Again, same thing. We have our numbers 0 to 9. And if it's in this range, then it will return true. So here we are to finish this line. Okay. Finish this line like the example. What's your favorite short string? Try a letter, try a number. Yeah. So you can see for the is alphabetic and is numeric functions, we are returning or we are passing the your character as an argument. So we have to define that variable, your character. And then we can assign, let's start with a letter, maybe G. Am I missing something? Oh my God. The semicolon. Okay, sorry. Also mutable. We have to make the variable mutable. Yes, so it's alphabetical, but let's say we use a number like 6. Numerical. And then let's see if it's neither alphabetical or numerical. So we can use maybe an exclamation mark. Yeah, it returns neither alphabetic nor numeric. So that's what's happening under the hood for this code. Now we can move to the next one. That's primitive types 3. Destructure the cat tuple to call print on each member. Okay, so as I mentioned before, for our primitive types, we have both static and compound. And under compound, we have the tuples, and they're fixed in size. Normally, when you define them initially like this, you cannot add any values or take away any values after that. And then tuples can hold values of different types. So in this case, for example, we have Fari McPherson, which is a string, and then we have 3, which could be a fell to 52. Sorry, Fari McPherson is a short string, which means it's a fell to 52. And 3 could also be a felt, or it could be an integer. So you can also add a Boolean. You could also add a Boolean in this tuple and it would still work. So in order to destructure, we're going to do some pattern matching using the let keyword. So we're just going to have the name and age variables in some parentheses. Yeah, so this takes the first value in our tuple and assigns it to name, and the second value in our tuple is assigned to age. And that's how you destructure it. Yeah, name is that. This is the, again, hexadecimal value of Barry McPherson, and age is 3. Okay, so yeah, Next is primitive types 4. Modify the integer types to make the tests pass. Learn how to convert between integer types and felts. So here we have a function that takes x and y of type U8 and returns U8. Then we have sum of big numbers. Also takes U8s and returns a U8. Convert to felt, and then convert felt to U8. Okay. Another to do here, modify this test to use the correct integer types. Don't modify the values. Okay, let's start from the top. So to do, modify the types of this function to prevent an overflow when summing big values. Okay, so U8 is a type, is an integer type. So for integers, we have both unsigned and signed integers. For unsigned, you use the U prefix and then the number of bits. So there's U8, U16, U32, U64, U128, and U256. But there's also U size, which is another way of calling U32. And the greatest value that U8 can store is 2 to the power of 8 minus 1, which is 255. And if we want to sum bigger values, let's say, for example, you have 255 here and you're adding 1, it will cause an overflow, which will wrap around, and then it will return 0. So the result is 256, which is an overflow for U8, and it will return 0 instead of 256. So in order to handle big values, you just need to increase the number of bits for our integer type. In this case, we can have U16. And since we're adding two U16 values, our return value is also going to be U16. And then here to do return x as a felt 252. So in order to convert the type, we're going to use, we can either use the into trait or the try into. So in situations where you're converting to a type that is bigger than the original type, then you can just use into, because we're guaranteed of success. So in this case, a U8 can definitely fit into a felt 252. So we're just going to use into to convert the type. So we just say x dot into. Sorry. Yeah, and then for this one, to do return x as a U8. So in this case, a felt 252 is larger than U8. So the chances of failing. And for this one, we're going to use try into instead of into. So the try into returns an option, and the option enum. So it can be either sum, sorry, not into, but try into. And then to access the value that has been returned by our try into, so either some value or none, you have to unwrap. Yeah, so in the case where, let's say if this was U16 and here was still U8, in that case, we would still use try into because U16 is larger than, or it stores more bits than U8. And then another thing, modify this test to use the correct integer types. So we're using the sum big numbers function, which is taking in U6. So for our values here, we're just going to update the bits to U16 and also the return. Yeah, our tests have passed. Okay, so I hope you guys have understood the concept of type conversion using into and try into. So you just have to compare the destination type with the source type. Okay, and with that, I think we can move to the next exercise. If you have any questions, please feel free to ask in the chat. Okay, next is operations 1. Integer types implement basic comparison and arithmetic operators. Failed 252 operations should be avoided where possible as they could have unwanted behavior. So to do, return the solution of x cubed plus y minus 2. Okay, yeah, so a little bit on this. So as we had previously mentioned, for felt 252, it's the default fallback type for our variables in Cairo, but it is not advisable to perform operations on a felt 252 because it doesn't have the security, it has not implemented the right security measures to handle cases like an overflow that we have talked about. So it may return, for example, if you have some numbers and you perform multiplication on them, but they're of felt 252 type, then the result returned may be, it may be wrong because felt 252 cannot handle such operations correctly. So anytime you're dealing with integers, it's highly advisable to specify the integer type. Okay, so here res is going to be the solution of this. So you can just define that variable res, and it's going to be x cubed. So that's going to be x times x times x. Then we add y and minus 2. Then we return res. Yeah, our test is running correctly. Also, another thing to note about return types is when if you were to use the return keyword, then you have to have a semicolon at the end. But if you don't use the return keyword, then also omit the semicolon at the end of that line. This is wrong, and our compiler is not, it's going to panic because we have not used the return keyword, but we have added a semicolon. So this is what works. Either of those can work, but you have to take note of that. Okay, let's move to the next one. Yeah, operations 2. Remember last time we calculated division in Cairo 0. Now Cairo 1 has native integer types, the ones we've just discussed, also usize, which support more operators than felts. And always watch out for overflows. Let's try to use them. So here, we're going to calculate the modulus of x and y. So modulus is just the remainder of a calculation. For example, division, actually the remainder of a division. And then floor division, calculates a floor division of x and y. So in Cairo, when you perform a division, it will round the response down to the nearest whole number. That's why we call it floor division. Then here we're going to be calculating the multiplication of x and y. Okay, so let's do that. Let res equal x mod y. And then here letters equal x divided by y. Then here is just letters equals x times y. Yeah, and some test cases. Our tests have passed. So that's basically just the operations on the integer types. Okay. I hope everyone is okay so far. Our next exercise is if one. Okay, so we have our function bigger that takes in a and b of type u size, returns a u size. Complete this function to return the big number. Do not use another function call or additional variables. Okay. So here we're just going to have if a is greater than b, then we will return a, else we'll return b. Yeah, and that works just fine. So we can move on to the next. If 2.Cairo, get the bar for fuzz and default to bars tests passing. So function, complete this function using if, else, if, and or else blocks. If fizzish is fizz, return full, fuzz, return bar, anything else, return buzz. So, okay, let's start. If fizzish is fizz, our return value is full. Else, if fizzish is fuzz, then here we're going to return bar. And then our last else, we're going to return buzz. Yep. So that's just it for this exercise. Okay, next is functions. Functions 1. Okay. Okay, so the issue here is the function is not found. We have not declared this function. We can't call a function that has not been defined. So to solve this, we just have to define that function, call me, like that. And it's the same thing with variables as well. You cannot call variables or functions that you have not defined. So I think we can move to the next one. I think that's functions 2. Yeah. Function call me that takes in num and prints this. So the issue here is we have not specified the type of our argument. And again, you have to remember that Cairo is a statically typed language. So you have to specify the type of this argument in our function signature. So we can have maybe U8. And then when you call your function in the main function, you also have to pass a value as an argument. So it prints out num is 3. Okay, so I think now we can move to function 3, but just a minute. Okay. Functions 3. Yeah. So the issue here again, very much like functions 2, is, as we had said, when you call this function, you have to pass a value as an argument. And you can see here, we've called our function, but without a value. So we have to pass a value. So we can put maybe 54 or whatever value could work, as long as it fits in this type. Okay, I think we can move to the next one. That's functions 4. This store is having a sale where if the price is an even number, you get 10 Cairo bucks off, but if it's an odd number, it's 3 Cairo bucks off. Don't worry about the function bodies themselves. We're only interested in the signatures for now. So we have our main function. Original price is 51. Sale price is sale price. So we have a function called sale price that takes in the original price as an argument. And in our sale price function, if the price that is passed is even, then it will return price minus 10. Otherwise, it will return price minus 3. Then we also have an is even function to calculate if a value is even. So the number divided by 2 has a remainder of 0. So again, we've been told that we're focusing on the signature for now. So our focus is on the return type. And our return type is going to be U32, just because we're performing an operation on a U32. Yeah, and it works. But if you were, remember, if you were to use a different type like U64, that will not work because our type is U32 and we're still performing an operation on a U32. Okay, I think we can move to the next. I hope everyone is okay so far. Our next exercise is okay, awesome. Our next exercise is quizzes 1. So we have Mary is buying apples. The price of an apple is calculated as follows. An apple costs 3 Cairo bucks. If Mary buys more than 40 apples, each one costs 2 Cairo bucks. Write a function that calculates the price of an order of apples given the quantity bought. Okay. So, okay. This is our function, calculate price, and we've been told that we are going to be given the quantity bought. So that's our argument, basically. And we can call it apples. and it will be, we can use U32, and then it returns the price of the total number of apples. So it should return, we can also have U32 for that. And then in our function, we're going to do if Mary buys more than 40 apples. So if the number of apples is greater than 40, then the price is apples times 2. That's what we're going to return. Otherwise, it's going to be apples times 3. Yes. Let's try again for this. Okay, let's just wait for this to update or to reach 2 quizzes. Oh, I think, yeah, it's there. It's there now. And you can see our tests are passing. So that was just it to implement the if function with the comparison and multiplication operation. So we can proceed. Okay, for the next exercise, it's loops 1.Cairo. Make the test pass without changing any existing line. So for this one, we have to add a condition for the break keyword to work, because we're asserting that the counter is equals to 10, meaning that our loop should stop at 10. So it should break. So if counter is equals to 10, if the counter is equals to 10, then we're going to break. And then otherwise you increment. Yeah, and our test is passing. Yep. So we can remove this comment. Okay, so the next exercise is loops2.cairo. To do return a value from the loop and assert that result is equals to 5. Result should be 5. So with this assertion, what it tells us is that our loop should stop when the value in counter is 5. And that means we have to implement our break in here. So we're just going to use the break keyword and then plus our, or the value that we're returning, which is counter. And a semicolon. Yeah, so anytime you want to return a value from a loop, you just break with that value. And then our next exercise is going to be enums 1. So to do, define a few types of messages as used below. So in our main function, we have the quit, echo, move, and change color, meaning that we have to specify this variance in our enum. I don't know, can anybody try that in the chat? So we're going to have 4 variants in our enum, and it's going to be basically this 4: quit, echo, move, and change color. So we're going to have quit, echo, and they are separated by a comma, move, and change color. Yeah, and that's how you set the variance of an enum. Basically, this is just the options that are in that enum. And we can move on to enums 2. Define the different variants used below. So again, we have quit, echo, move, and change color. But as you can see, echo, move, and change color have some associated values with them. So that means when we're defining this variance in our enum, we have to specify the types of the associated values. So I want to give this chance to somebody to try in the chat. Is there anybody who wants to try? And you can refer to what we've done previously in enums 1. So it's almost the same thing. We just have to specify the types. Anyone? Is anyone trying? Okay, I guess I'll just do it then. So in our message enum, we'll have quit. So for quit, we don't have an associated value, so it's just going to be quit. And then we have echo. And here we have a short string, hello world. And as we said, short strings are basically just felt to 52. So the colon and then specify the type. Then we have move. and the associated value is a tuple of integers. So we can say I guess let's just use U16 and U16. And then we have the last one is change color, which is also a tuple. The associated value is also a tuple. So colon, then U8, can have U8 for them, or any other number of bits, like 3. Yeah. Yeah, that's it. So anytime you have, or the options in your enum have an associated value, you just specify the types like this. Okay, we can carry on. Yes, Tosin says the Cairo book will really help in solving these problems. Yeah, that's true. And it's very advisable when you're tackling these challenges, you use it hand in hand with the Cairo book. It has very deep and clear explanations of what is happening under the hood in the Cairo programming language. Okay, so I think we can move on to the next one. Wait, okay. So next is enums3.cairo. To do, implement the message variant types based on the usage below. So here we have a struct called point that has 2 integer values. And then we have a struct called state. Color is a tuple, position is of type point, and quit is a boolean. Then a trait for the state struct. So traits are basically just a way to define methods for a specific struct, and they usually just contain the function or the method signatures, and then you can implement them below that. So we have the change color function that takes in a tuple of new color. Quit echo takes a felt 252. Move position takes p of type point, and process takes in a message. So okay, here we're just going to define our change color, echo, move, and quit variants in our enum again. So there's quit, there's echo. Echo takes in a file 252. It's file 252. Then we have move that has it's of type point. And then we have change color. That's a tuple with 3 values. Okay. And then the next thing, create a match expression to process the different message variants. So yeah, here we're going to match our messages. So this message that we're taking in. So for our variant quit, we're just going to match it to the quit function. So that's self.quit. Yeah, and it doesn't take any value. And then for our echo variant, echo has an associated value, which is of type Fel252. So we can just call it S. And then we match it to the echo function or method with S as an argument. Next is move. Move. For move position is taking P of type point. And then we're going to match it to self dot move position P. And then finally for change color, which again has a tuple, takes in a tuple. This is the function. We're just going to call our argument new color. And then we're going to match it to self dot change color in our argument again, new color. Yeah, that should work. Yes, our test is passing. So what we've done here, first of all, is just like enums2. For each variant that has an associated value, specify the types. And then we have some methods for the state struct that we had defined. And then we're matching each of these methods with an enum variant. And then we can move on to our next exercise. That's options 1.Cairo. Okay. This function returns how much ice cream there is left in the fridge. If it's before 10 p.m., there's 5 pieces left. At 10 p.m., someone eats them all, so there'll be no more left. Maybe ice cream takes in time of day and returns an option. We use a 24-hour system here, so 10 p.m. is a value of 22 and 12 a.m. is a value of 0. The option output should gracefully handle cases where time of day is after 11 or after 23. So complete the function body. Remember to return an option. So an option is a special kind of an enum that returns either some value or none. And so it's good for error handling in case your return value, there's no value that has been returned, it gracefully handles it. Okay, so let's see our tests. And if maybe ice cream. So this is the time that is past 9. So that's 9 a.m. It should be 5. Right? And then for 10, it should also be 5. So anytime before 10, there's 5 pieces left. 23 is 11. That's 11 p.m., which is already after 10 p.m. So it returns some value 0. And 22 is 10 p.m. itself. It should also return some value 0. 25, that's after 10 p.m. So it should return none, meaning that there's no ice cream left. So let's implement that. So we're going to use the if time of day is after 11 p.m., then I'm pretty sure it should return none. So let's try with none. So it should return option dot none. And then else if time of day is before 10 p.m. So that's going to be less than 22. Then it should return 5. So some value, some 5. And other than that, it should return some value 0. Yeah. So also another thing about getting the value that has been returned, but from an option enum, you have to unwrap. You have to use the unwrap to get the value that has been returned. And then there are also the is some and is none checks that just compare and return a boolean, whether the return value is either some value or none itself. To fix this test, how do you get at the value? Yeah. I've already mentioned about getting to the value, you have to use unwrap. So for let ice creams, maybe ice cream 12, assert that ice creams is equal to 5. So if the time is 12, that means it's before 10 p.m. It should return some value 5. And in order to unwrap that, just add this. Yeah. And that works. The tests are passing. And then I think we can move to options 2 now. Just remove this comment. Use the isSum and isNone methods to check if optional target contains a value. Place the assertion and the print statement below in the correct blocks. So our function test options, we have target variable, and in it we have the Starklings value, and then optional sum, it returns some value target, none returns none. Then we're calling our function with these two values. So this is our argument optional target that we want to check if it returns either some or none. So if optional target dot is some, and we can add this. Yeah, so this line yeah, our assertion will be inside here. So if it returns some value, so if it's true that this, for example, if we pass target to our simple option function, if there is a value, then isSum will return true. And if it's true, then our assertion will work because Starklings is a value inside there. Else, we're going to print this statement. Yeah, and that's how isSum and isNone. But if we've actually not used if none, so let's use that. So optional target dot isNone else if we're going to print this statement. So as you can already guess, the isSum and isNone functions return a boolean, so either true or false. And if it's true, then for example, if isSum is true, then our value is stored in target. Yeah, that's how it works. So we can move to another one. And I think probably we'll stop at options 3, and you can have the rest of the exercises as an assignment. And like Tosin already said in the chat, you can use the Cairo book along with these exercises because the Cairo book also provides clear explanations for, like, the exercise is actually based on the Cairo book. Okay, so I think we can move to options 3. Struct student has name of type field 252 and an array of courses that has the option type, and then display grades, and our arguments are student and a snapshot of the struct and an integer index. Don't mind these lines are required when running recursive functions. Okay. So if our index is 0, then we create a new array and append the student name and the grades. No, we print a message with the student name / grades. Then if the index is greater than or equal to student.courses.length, then you return an empty value. And then let course equals to student.courses at this index. Modify the following line so that if there is a grade for the course, it is printed, otherwise print no grade. So here we're just going to use the isSum and isNone again, because since our array of courses has an option, it can be either some or none, some value or none. And if there's no, if the return is none, then that means there's no grade and we should print no grade. And then display grades, we call this function again with the index +1. Okay, so if course dot isSum Then we're going to have this line, this print statement. And then else if post dot is none, then we'll print that there's no grade. Outline. I think that should work now. Okay, let's just wait for this to catch up. Does anybody have any question?
Okay. Looks like we do not have any more questions. But yeah, pretty much I think you have really done the most, like taking them through how to tackle, challenges and how to complete them step by step, just really, really amazing. So do you wish to continue, or maybe we can let them complete? I feel like they should complete the other quizzes.
Yeah, so I'll just wait for this one to compile successfully, and then I can leave the rest of the exercises maybe as an assignment for
Yeah.
them.
Yes, exactly. Okay, sounds good.
Okay, yeah, and it's working, it's compiling successfully. So the trick here was just to use isSum and the isNone methods to check if there's a value that is stored for that course. So the next exercises, as I've said, I'll just leave them as an assignment for you guys. And when you're done, perhaps you can share a link to your repository with the solutions. And feel free to ask any questions that you may have in the Telegram chat. Yeah, and that's it from me today.
Wow, thank you so much. This session has been really an eye-opener to me, and I assume to many more that have followed through this far. So thank you so much, and I hope that each one of you here actually has been added to the to the Hardao Dev Camp GitHub. So that's the place where you will need to create the repo and complete the challenges and have the code on there, because we will use that as part of our criteria for determining the builders that have actually gone through the Basecamp completely and completed the assignments and the tasks, completed Starklings and completed Starklings as well as built a project using Scaffold Stack. The sessions that we had last week with Carlos from Scaffold Stack. So yeah, so those are some of the criteria we'll be using to determine the people that actually qualify to get this bounty, and also to get finally a certificate to show that you have gone through Basecamp. And we will be announcing more opportunities next week. We will have another session, the last session for StarkNet Basecamp, virtual one, with Emily from Only Dust to introduce you guys to open source contribution. And we will have other exciting opportunities, exciting updates to give you all. So I hope to have you on there as well. So let me know, just ping me, just drop your GitHub in the StarkNet chats, and I will add you to the GitHub as soon as possible. And also please double check your notifications on GitHub in case you are missing those. And yeah, I think should be fine. And you should, or maybe if you don't see a notification, but you should see your notification in the GitHub. You can as well check your email. Usually they also send a notification there just to inform you that you have been added to an organization. So yeah, feel free to check those both. And then if you can't really find your notifications, then let us know and we will try to figure that out. But yeah, otherwise, thank you everybody. Thank you for joining. Thank you for your consistency. We really appreciate it, and we'd love to see you all excel and be impacted. And yeah, I hope that you are doing amazing and that we will see you again for our next session next week. So this week will be just a self-paced week, especially with Starklings. It's going to be a Starklings week. So just completed the remaining quizzes, the tasks, the assignment that Lynette has given, and then we shall be checking those next week. Hopefully by end of next week, we should have at least completed all of them, and also just started to build your solutions and your products and your projects on Scaffold Stack on and created a repository on the GitHub. Okay, I think that's it from me. I don't know if anyone has a question.
Yeah, can you hear me, Lavender?
Yes.
Yeah, I can see there's one question in the chat. What is the difference between using Starklings app and this repo? How you can share progress with others from Starklings.app. So on Starklings.app, I think you can connect your GitHub and you can keep track of your progress. So just make sure you connect your GitHub if you're using Starklings.app. And then Ian also says, realize it's not that hard watching Linus go through those exercises. Yeah, it's actually not hard. And they also provide a systematic way to go through the Cairo book in case you're feeling overwhelmed. The exercises can help you go through it in an orderly manner. I don't think there's any more exercises. Oh, sorry, questions.
Okay, thank you. Thank you for that. Yeah, so as we've had, those are the differences. But yes, feel free to, I don't know, use whichever fits well with you. But we would love to see your repos on GitHub so we can actually be sure that you did it and you completed it. And that's one way we could definitely know that. And also feel free to share your progresses, even on X, tag us, let us know what, in case you're facing any challenges, let us know in the chat. And yeah, so I don't know if they can, so someone is asking if I walk through the app, do I still need to add a repo on GitHub? So how will we know? Is there any other way that we'll know they actually completed?
I think it's advisable to add the repo on your GitHub. So just work from your code editor
Yeah.
as if that's possible. It's highly advisable.
Yeah. Plus it will show like engagements on your GitHub, commits, etc. Like what you have your GitHub want to be like. So less engagement on there. So yeah, and this is just to make our work easier also. It will just be advisable, makes sense to put it on GitHub. Okay, thank you all for joining. I wish you all blessed nights and bye-bye. Thank you, Lynette, again. Yeah, feel free to share with us the resources that you used in case anyone would need those. And as always, we will update um, the recordings on Notion page. And don't worry if you're getting errors with GitHub. Yes, we understand that that link was short-time link, so it expired sooner than expected. So we encourage each one of you to drop your GitHub links in the StarkNet chat so I can add you manually to GitHub. So no worries if you're getting an error, we will still add you manually. Cool. Okay. Bye, everybody. See you next week.